Diving into chapter 3, we're going to be covering quadratic functions and equations. So how do we graph it? What do we do with them? How do we solve the equations, as well as inequalities, which is kind of interesting because up until now we've only seen linear inequalities. So we're going to jump into quadratic. What does quadratic mean? It means that your highest power x is raised to the second power. So you see x squared. So coming up into this, we had seen it a little bit in chapter 1 when we had to do domain and we factored on our focus on factoring and all that kind of stuff. And we had talked about taking square roots, and you can't take square roots of a negative number. Well, this is what we do now. Is 3.1 is actually introducing the complex number system, and this is where you feel like you've been lied to your whole life. There is such a thing as a square root of a negative number, okay? It does exist out there. There's a whole new way of graphing, if you're interested. It's called the complex number system. We are not going to dive too deeply in it other than introduce us to this new number that we never knew existed and some quick calculations with it. So your mind is blown. You really do feel like you've been lied to. You're just like, I thought I couldn't have a negative under a square root, but you can, okay? You can't in the real number system, but you can in the complex number system. So it says, some functions have zeros that are not real numbers. The complex number system is used to find zeros of functions that are not real. When looking at a graph of a function, if the graph does not cross the x-axis, then in our normal real life, there's no x-intercepts, but that just means there's no real numbers. There's just complex numbers, all right? So let's find the x-intercepts of this. If you remember x-intercepts, you let y equal 0. We kind of talked about that a while ago, okay? So we're going to make this function, which is 0, the f of x part, and we're going to solve for x. Well, how would you solve for x? Let's move 1 over to the other side. So you get negative 1 equals x squared. And we technically haven't learned this yet. I know, Gavin, you've used it a little bit before in solving. And we're going to actually learn this like tomorrow in 3.2a. I probably should make it 3.1a. But to undo a square, you take the square root. And so that means we would take the square root of a negative 1 to get x. Because square and square rooting are undoing each other. And you're like, no, I'm not supposed to take a square root of a negative. That's all kinds of wrong there. And so what we just defined right there, that square root of negative 1, is this complex number, okay? So notice it's right here. We call it I. So you know how we use the symbol pi for 3.141, you know what I mean? Sometimes we use symbols and letters for actual numbers. So this is technically a number. It's the square root of negative 1. So what's that mean? If we go around, what do we get when we square I? We get negative 1. And again, that seems like all kinds of wrong, because when you square a number, should a square of a number ever be negative? No. But when you square a complex number, you potentially might get a negative. So what we're going to do is we're going to reduce these radicals, but now we're going to do it like we did before, where we're going to find our little factor trees and the pairs come out. But now there's going to be negatives, and this is where I use like the weirdest, but you literally pop out an I, act like you're popping out an I. Not really. If you see a negative under the square root, that just is an I coming out, okay? So I'm going to show you just this first time the way the book teaches it, and then I'm going to just say, just do this, okay? So how the book teaches this, guys, on A, they would write this as negative 1 times 7, both under the square root. So they say the square root of negative 1 times the square root of 7. So all they did was separate this negative from the number. Do you guys see what they did? But what did we just say the square root of negative 1 was? I. So this is just I root 7. Or, guys, if you like root 7i, that's fine. Just make sure your I is outside of the root. Because my math lab, you'll have to like arrow, key over so it's outside of the root. So all we're going to do is we're going to break down our radicals if possible. 7 doesn't break down, so it's just the square root of 7. But if you see a negative under there, let I pop out. Okay? So what is this? Well, what's the square root of 16?
8.
Not 8.
4.
4, right? You just do this. Who can come out? 4, and then how do we take care of that negative underneath? It just becomes I. If you want to do it like this every time, you can. You don't have to, though. All right, what does this negative mean? It just means your answer is negative, right? So we're going to have a negative. Can the square root of 13 break down any?
No.
No, so he's going to stay the square root of 13. But then what does that negative under there come out as? I. Is that okay?
That one's kind of tricky.
That one's tricky because there's a lot going on. So the negative just means keep my answer negative. The negative on the inside means, hey, I'm the square root of -1. So he can come out as an I, which just leaves 13 hanging out. And if 13 could break him down, but he can't. So he stays 13. Let's look at this next one, 64. What's the square root of 64, guys? 8, right? Who's already on the outside, though?
Negative.
A negative. So we're going to have a -8. Is that okay? Because the square root of 64 is 8. And then what's that negative under the square root going to come out as? I. All right, this one we're going to break down a little bit. What are any two numbers that multiply to be 48?
16 and 3.
16 and 3. And why does that help us? What's the square root of 16? 4. So, how does the square root of 48 break down? The 4 would come out and the 3 would stay in the root. The 4 would come out and the 3 would stay in the root. And then how do we take care of that negative under the square root? He comes out as in I. So it's basically what we did in the earlier sections. It's just now we have that -1 floating around that comes out as I.
Could you put that I on the other side of that?
Yes, yep. I typically kind of like the I in front of the root because I don't have to question if the I is inside the root or not. You know, so because some of us get a little sloppy. I don't know if any of you guys have seen your worksheets and looked closely, but they're hard to grade sometimes with our penmanship, right? So if you're kind of like this, is the I part of the root, not part of the root? I don't know. And so you can write this as I 4 root 3 or 4I root 3. Any of those are fine, okay?
I would say that I would rather put the I in front.
The I in front makes me know you know it's not part of the root, and I like that. All right, let's look at the back real quick. So now that we know that we have this complex number, we can have a whole new number system, all right? So the whole new number system is made up of a real part, which is A, so that's the real part, and B are real, and then obviously the I they call imaginary. And I don't like that they use the word imaginary because imaginary makes you think made up, and it's not made up. It's a legit, like I took a whole math class over complex numbers in college. It's a real number system. You can graph them, you can do functions if you need to, all kinds of stuff, okay? But like A and B would be numbers we're used to, like 3 and 2 or -8 and 5, that kind of idea. So we can actually do math with them. And how we do it is you think of like terms. If they have an I with it, add the I's together. If it's just constant, add the constants, all right? So notice here we have 8 plus 6I, which is one complex number, plus 3 plus 2I. That's one complex number. But what are we going to do? We're going to add the real parts together. So what's 8 plus 3? 11. And we're going to add the imaginary parts together. What do you get? What's 8 plus 2? Why did I say 8? I'm saying the answer. That's why you guys are confused. What's 6 plus 2? You get 8, but who's behind them? The I. Sorry about that. Is that okay? Part B, the exact same thing, but what do we have to be careful of with this minus on the outside? We got to distribute him to both parts. Okay? So I'm going to just go ahead and write the part B without parentheses. So I'm going to write it as 4 plus 5I minus 6 plus 3I. Are you okay with that? I just distributed my negative to both parts. And then do what we do. Gather your real parts. The 4 minus the 6, what will that give us? -2. And you can throw that in your calculator, guys, if you need to. And then the 5I plus the 3I will give us 8I. All right. The last one's multiplication.
So you distribute.
We're going to distribute. And then we just have to keep in mind what I squared is, because we're going to get I times I, which is I squared. And we got to remember we know that's -1. That's the only thing that's weird other than just a normal FOIL or distributing, okay? So let's look at what we're going to do. We're going to do 1 times 2, which is just what? 2. And then we're going to do 1 times 3I, which will just be 3I. Are you guys okay on that part? We distributed the 1. Now we're going to distribute the 2I. The 2I times the 2 will give us what? 4i. And then the 2i times the 3i will give us 2 times 3, which is 6. But then I times I, which is I squared. Is that okay so far? Are there any questions on that part?
But I squared is
-1. So that's what I'm going to do. So I'm going to write this as 2, and I'm going to go ahead and combine these. 3i plus 4i gives me what? 7i. And then like Riley said, we just talked about how I squared is a -1.
should be, yeah.
So technically -6 there. Is that okay? And if you know that, you can go right to -6. So this is really 2 plus 7i minus 6. So again, I kind of have these real parts that I can combine. So what's 2 minus 6? -4 plus 7i. So, not horrible, but guess what your calculator can do? Complex numbers. Did you know that? So go ahead and get your graphing calculator out if you haven't. We first need to tell our calculator we want to be in the complex number system.
W mode.
And it is in mode, I believe. I got to remember how to do this myself, guys. Eek. Okay, so let me turn this on. And I believe it is mode. And if you come way down here, there's real and then a plus bi, and then there's re raised to the theta I, right? And you guys probably have the real highlighted, but I want it in the a plus bi. Do you see what I'm talking about? So you probably have that right now, but go over to a plus bi and hit enter.
Oh, I did the wrong one.
You guys, everybody see where that a plus bi is? And you can get out of there, okay? So you hit second mode. So then anytime you need to do math with the complex numbers, guys, I'd make them look like they are, like with the parentheses and stuff. But realize your complex number I is right above your decimal point on your calculator. So if you look right above your decimal point, you guys see the little I there? So you'll hit that second button I whenever we do the math. So just real quickly, I'll do B. A and B are identical, so let's just do B, okay? We're going to type in our calculator, parenthesis, 4 plus 5, and then where's your I, second period? You see that? And parenthesis, minus, parenthesis, 6 minus 3, second period, and you get your I, and you hit enter, -2 plus 8i.
Oh, wow.
So it did it for us. Okay. Honestly, I think adding and subtracting are not bad. That's not too hard. But it gets a little difficult with this multiplication. So let's just see if they can do that as well. So in the multiplication part, let's do parenthesis 1 plus 2 second decimal to get our I. And then right behind it, parenthesis 2 plus 3 second decimal. Close off your parenthesis. So you should have 1 plus 2i times 2 plus 3i, and you hit enter, and what does it give you? -4 plus 7i. So that's kind of nice. So it takes into account, it knows that I squared is -1 and so forth. All right. Keep these not too far from us. The next parts are a little bit more complicated, but I'll kind of tell you how you can kind of use it to double check. So sometimes we need to know more powers of I. So if we're distributing and we have i's raised to these higher powers, we need to be able to break them down. So how we do these is always break it off. So if you get an odd one, break it off so it's even. So this is using rules of powers that we don't necessarily always remember. So guys, this would be I to the 6th times I to the 1st. So anytime you have an odd power, break one I off. And why? Because any even number, we can write it as a power of I squared. Okay?
-1.
Exactly. So if we can get to a number, it's a lot easier to deal with, okay? So any odd power, I just break one I off, and then just your remainder will be some even number. So like she said, we can write this as I squared to what power? Well, if we need it to be to the 6th power, this technically is a what out here? A 3. And again, it's using those rules that we don't necessarily remember.
Wait, how'd you get a 3?
Because I know that I want I to the 6th, right? I want to represent I to the 6th, but as a power of 2. So the rules of multiplication, 2 to 3 is 6. So just honestly divide that number by 2 and you'll get your remainder. So 6 divided by 2 is 3. And who's hanging out right here? Just I. All right, why do we care? Well, Riley reminded us, what is I squared?
-1.
-1. So we have negative 1 cubed times I to the first. But what is negative 1 cubed? That's just negative 1. And what's I to the first? That's just I. And what's negative 1 times I? That's just negative I. Isn't that weird? So I is cyclic, okay? Because it can be 1, I, negative 1, or negative I. It's cyclic. It's always one of those 4. So depending what power you get, always branch off 1 if it's odd. Divide this by 2 so you can get it I squared in there, and whatever your remainder is, that's what that power is. So here, notice right off the bat, it's an even, right? So I want to write this as I squared, but it'll be I squared to what power? If it started as 12, what do I need? You got it. See, you're seeing it already. What is I squared?
Negative 1.
Negative 1 to the 6. What is any negative number raised to an even power?
A positive.
Positive, so that's just...
1.
Isn't that crazy? I to the 12th power is another way to write 1. So can you kind of do it on your calculator? Kinda, but you have to, I think it's harder. I'll show you what we can do. So in our calculator, make sure it's on the screen because I know people are probably going to be watching this. I'm going to do second decimal. I'm going to get my I up there, and then I'm going to do caret 7. I'm going to raise it to the 7th power. When you hit enter, do you guys get something like that?
I tried to do that a little bit ago.
And it looks weird, right? I just want to remind you, because this is something that we're not familiar with, but anytime you have E, it's scientific notation. So like this is negative 3 times 10 to the negative 13th power, meaning it's a really, really small decimal, aka it's basically 0. So this part's 0 minus I, what is that? Negative I. So they do it in the scientific notation where this is basically 0. And so 0 minus I is just negative I. So that's a way you can kind of check, but it's kind of more complicated. Here, though, when it's an even power, it will work out perfectly. So let's do that. We'll do second decimal, and we'll raise it to the 12th power. And when you hit enter, oh, no, I lied. It did it the same way. So then, again, this is still the same kind of idea. This 2e to the negative 13th is basically 0. What's 0 times I? 0. So what does that leave you with?
1.
1. Okay, so if you ever see that e to a number that has it's a decent number with a negative, that's basically 0.